Do 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 do. So in this video, we're going to talk about momentum. So we hear momentum thrown around in everyday language all the time, especially in sports. We say this team has all the momentum, and that actually comes from physics. Momentum is actually a physics thing, and we can define it. I know I mentioned sports and there's not really much sports going on right now. So if nothing's happening, we could actually say there is no momentum. And let's take a look at why that actually makes sense. So what momentum is actually quantity of motion. That's the way that Newton described it. And what that really means, this quantity in motion, means that it is, we can say, a mass in motion. So let's just write here, mass in motion. And momentum is equal to the product of an object's mass and its velocity. So product just means, product just means multiply. So when we want to write momentum, we actually use the letter P, and it's a vector. So we say that momentum is equal to the product of an object's mass. We know what mass is. It's just represented by m. And its velocity, we know that as well, is v. And velocity is a vector. So this is actually our formula for momentum. I'll just label them here. P is momentum, m is mass, and v is velocity. So I don't think we need to label those. What's the actual unit, though? So the unit of momentum, if we have that it's mass times velocity, well, let's just fill in those ones. Standard unit for mass is the kilogram, and the standard unit for velocity is meters per second. So guess what? The unit for momentum is kilogram meters per second. So this is our unit of momentum. And this is actually a really easy formula to use because it's just multiplying two things together. Again, when we're talking about momentum, we're talking about mass and motion. So if you increase the mass, you're going to increase the momentum. If you increase velocity, you're going to increase the momentum. So the faster or the bigger something is, the more momentum it has. The smaller it is, so the less mass, or the smaller it's going, the less momentum it's going to have. So you think about if you throw two things at your sibling, whichever one is bigger and has more mass is probably going to hurt more. Why? Because it's going to have more momentum when it actually hits them. Let's look at Newton's second law just briefly here and see how momentum plays into it. So Newton's second law is that force equals mass times acceleration here. And actually, we should say the net force is mass times acceleration. So let's just look at how we can turn this into something with momentum. So let's keep mass the same. Acceleration can be written as Vf minus Vi, those are vectors, divided by the change in time. Now all I can do is just expand this out and multiply those. So we'll have m times Vf subtract m times Vi. So I've expanded the top. And on the bottom we still have delta t. Why does that get us anywhere closer to momentum? We'll take a look at this. Mass times velocity. What is that? That is the definition of momentum. So this is momentum. This was the velocity final, so we can call this momentum final. This was the same thing, but instead of final, it's initial, so we'll say subtract momentum initial divided by delta t. And we can even go one step further and simplify this a little bit further and say pf minus pi, and I should make those vectors. So the final momentum minus the initial momentum is just change in momentum divided by change in time. So the sum of the forces is equal to the change in momentum divided by the change in time. So take a look at that. Newton's second law actually can be rewritten in a way that includes momentum. So let's actually do just a quick question about momentum here. So, example, which has more momentum? Your 194 gram iPhone 11. Yes, I looked that up. That is how much it weighs. So if you have a case on it, it's going to weigh more. So which is going to have more momentum? Your iPhone 11 when it hits the ground after being dropped from 1.20 meters. Oops. Or a 440 gram soccer ball hitting you in the face at 2.5 meters per second. Yes, I also looked this up. This is right in the middle of the FIFA regulated mass of a size 5 football for all you people that call it football rather than soccer. And, you know, I always come up with my examples from my own experiences. I recently got hit in the face by a soccer ball. Thank you, Katie, my wife. So which one has more momentum? So let's take a look at the iPhone first. So iPhone. Whoa, that was neat how it changed colors. Okay, so we know mass is 194 grams. If I want to know momentum, I'm supposed to do mass times velocity. So what do I need here? I need to know how fast it's going when it hits the ground. So how am I going to figure that out? Well, I know a few things here. That would be VF that I'm looking for, right? So I don't know that. VI, when you initially drop it, is going to be 0. I know the displacement it has to travel is 1.20 meters. Let's call that positive. It's going to go down. What else do I know? Do I know anything else? I know the acceleration is positive 9.81 meters per second squared because gravity's pulling it down. That's all I know. So based on that, I could choose my correct kinematic equation, which is VF squared equals VI squared plus 2AD. Let's fill everything in here. We have VF squared equals 0 squared plus 2 times 9.81 times 1.20. So we have VF equals 2 times 9.81 times 1.20 and the square root of that. So if I plug that into my calculator, I get 4.85 meters per second. So that's how fast it's going to be going when it hits the ground. Let's plug that in up here. So my mass was 194 grams. We need to convert that to kilograms, right? Mass is always in kilograms. So there's 1,000 grams in a kilogram. So we just divide that by 1,000. So we have 0.194 kilograms times 4.85. And we should say this is positive meters per second. And when I do that, I get positive 0.941. Nope, not meters per second. That should be kilograms. Whoa, meters per second. I don't know how we're getting this black in here, but that's cool. So just a little bit under 0.941. Let's do the same thing for the soccer ball. So it's 440 grams and it's traveling at 2.5 meters per second. So here's the soccer ball. I don't make you do any kinematic equation here. We can just go straight to our momentum formula, mass times velocity. So it was 0.440 kilograms times our velocity of positive 2.5. And when I do that, what do I get? Positive 1.1 kilogram meters per second. So the question said which had more momentum. So more momentum was the soccer ball. More momentum. So you can see the momentum formula is pretty easy. It's just mass times the velocity. Here we had to do an extra step for the iPhone. We had to actually find out what the velocity was, but the actual momentum calculation, very straightforward, just mass times a velocity. So using that formula, I want you to try these practice questions here, thinking about which would have a greater momentum here. You don't actually have to calculate. And then number 2, doing that quick little calculation using that formula.